Anybody having any idea about market basket analysis?
So we do market basket analysis to find out what customers are frequently going to buy. For example, if a customer is going to buy, if it is an apparel store, so if a customer is going to buy uh, trousers, then there is also a probability that he will also or she will also look for a shirt, and similarly will also look for a blazer. So it helps to using the we use it using the association analysis, and we try to find out the products that the customer might buy.
Correct. So the application side, there are many applications which will like kind of go through it shortly. So you can do something like a recommender system, right? In Amazon, Netflix. So those kind of things say that, right? If you have customers who have bought this, also bought these certain kind of items, which give a hint to a customer that, okay, I might also like to buy this. Similarly, Netflix or your Hotstar or your Amazon Prime, customers who have viewed or watched this kind of movies, documentaries also have seen this, right? So this is a very simple technique, something which is known as frequency analysis or association rule analysis. When I say simple, again, the algorithm behind it is also like kind of, there are a lot of mathematics around it. We'll not get into that mathematics, but at least we'll know that what does, how does the calculation happens, or how does this association rule gets generated, right? So again, it is not only in retail, a lot of applications can happen in healthcare also, right? Sometimes doctors or the medical professionals, they have to understand which kind of diseases, which kind of infections happens together, right? Accordingly, they can prepare the like kind of medicine, medications or injections for the like critically, whoever a patient who is critically ill, right? Because they know that whenever this occurs, other infections will occur most of the time. So it is not that they'll start putting those injections, but they will be keeping ready those whatever injections or tablets or what kind of medicines are required. Telecommunications, think about somebody who is buying certain kind of data limit, right? Or voice. Today's world, mostly it is voice over internet. But whenever earlier, what used to have a data, your voice and data packages used to be different, right? Along with certain voice packages, what kind of data packages certain customers are buying. Same thing can be applied in a banks also, right? What kind of savings account, along with that savings account, what kind of credit card a person is buying, right? So when we are, so the main objective or the what we have to remember is that what we are analyzing, right? We are analyzing something called transaction data set. So where the transactions has happened, right? So we'll have certain invoices. So let me just give you that file which I'm going to work on today, so that along with me also you can. Where is this? Just a moment. So this is a very big file. So let me just. Okay, around, oh, it is a very big file, 22 MB file. Okay. So I have put that in the chat message. You can download it. So when I say transactional data, let us open and try to understand what is this data about. So this is something again you have to remember. It is not that all the data set, at least you have to format data accordingly. So whenever you are carrying out certain market basket analysis. Let me share my screen. So this is a data set I have taken some, I think, from Kaggle or somewhere. So these are the invoice numbers, stock code, description of the like kind of that material or the item which is being sold, quantity, invoice date, unit price, customer ID, country, right? So when we say transaction data, think about this way. In a single invoice, so this is a invoice which number is 536365, right? 1, 2, 3, 4, 5, 6, 7. So in a single invoice, when a person has bought items, right? So what are the items he has bought, right? So item descriptions are given. right? And those item descriptions has to be unique, or stock code. Also, you can do, if I do not have descriptions, I can go along with the stock code. But this is the most important information which I have, right? I need to have this transaction data set. Quantity, if you see quantity, actually, as long as it is a one item, and that is certain limitations, at least in the SAS enterprise manner, where we are not looking into the quantity data, how much of that each individual item has been sold, right? What we are looking into, in a one transaction, what are the items being sold, right? So when those association rules are being created, right? So this is a single item, then this is a single item, and it will create item set, something known as, let's say, if I want to understand this item, let's say for example, this item and this item, whether this is item set, that means when a customer is buying this, whether customer is also buying this item and other item, this, let's line number 17 or 18. Like this, initially lot of item sets will be created. Out of that, again, carrying out simple frequency analysis, it will find out that which item sets are generating frequently, happening frequently, right? So the idea of showing you this, and we are going to use this data set today. What out of this, how many columns? I think 3, 4, 6, 7, 8 columns are there. Out of that, we are only going to use maybe one or two, like invoice number again, or customer ID. Who is that customer who has bought this, right? But most importantly, what is our objective is to understand, go through this description or stock code, find out whenever certain kind of purchase is happening. So this is a transaction. So this is a one transaction 536365, which is that invoice number. How many items that person has bought? So this person has bought a item of total 3 to 5 to 7 items. Similarly, what about invoice number 6? So he has bought 2 items, right? So these are each one transaction. On that transaction, how many items has happened, right? Then it will create a matrix structure of all the items there, and whether, so it is not about the quantity, whether in that one transaction whether that person has bought or not, yes or no, 1 or 0, right? And accordingly, so at the end, what it is analyzing, count data, how many times in a purchase these kind of items are being kind of preferred, or this kind of items being purchased together, right? So I'll show you through an example like in the slide, but again we are going to work on this data. So like Apurva mentioned, yes, it is mostly utilized in retail data set when we want to understand if you go to a retail outlet. So that is where they like kind of a placement of product happens. So if some of you have in marketing tech and retail management, one of the key challenges of any retailer is where to keep what kind of products, right? And that mostly somebody has put in certain business intelligence, they'll be utilizing this kind of association rules or market basket analysis. So again, remember, this is a correlation relationship. Though we are trying to find out, okay, this somebody is buying a apple, then he is buying orange, or somebody is buying egg, milk, bread. So that doesn't mean that somebody buying egg will propel or cause that person to buy milk. Where we are looking into, though the symbol will be showing something causing like right hand arrow sign, but actually it means correlation relationship. How many times somebody, let's say this is customer one who has bought milk, bread, cereal, customer two has bought 4 items, customer three has bought 3 items. So if I want to understand how many times people buy milk and bread together, right? So what will happen if I know that that is happening very frequently? So in a retail outlet, along when the milk containers are there, or milk is in the refrigerator itself, near to that I can put bread, right? Association rule mining. So this is where we are trying to find out what kind of rule or how those item sets are linked to each other. Association between different items in a set, then find frequent patterns in a transactional database, right? So we need to have a transaction data set. Only then we can use this kind of. So here we will have what kind of information? Transactions has happened. Then in each transaction, what are the items, right? If I have just the quantity number, I'll not able to use that. Like if you remember what we did in the earlier classes, whether somebody has taken an insurance, how much premium he has paid, and all those things. In those kind of data set, I do not have the transaction information. So remember the point of sales data. which happens in a retail outlet, or let's say if it is a e-commerce site, whatever in each day the transactions are happening, and it is getting updated in a database, right? So that is again being stored in a relational database. So whenever we are using this kind of market basket analysis, we have to depend upon transaction data set. Obviously, these are the some of the, not only in marketing, like I said, it later on we'll see it has also applications in other sectors. Increase customer engagement, boosting sales and increasing return on investment, improving customer experience. Customer do not have to search lot, right? If think about Walmart, it is like a big football field. If a customer can find whatever he or she wants very quickly, he will be very engaged, right? Rather than searching for all the products. Milk is at one place, bread is at one place, egg is at one place. If I know that if I can build a rule and I can understand that 90% of the times it happens that these three items are bought together. So I'll keep those items together, right, close to each other. Optimizing marketing strategies, campaigns. So this is where cross-selling and upselling happens, right? So cross-selling means you have an item along with that other item, right? Let's say I have milk. Along with that, I know that bread is being sold. So this is where the cross-selling happens, right? One more item in the same basket I can put. Upselling means one item, then the premium version of it, right? I can make that strategies, marketing strategies also. Identifies customer behavior and pattern, right? Obviously, that is our main objective. Then the point is how does it happen, right? So there are three important parameters: support, confidence, lift. Lift, if you remember, we also discussed during our decision tree, during our logistics regression, right? So same concept remains. If I believe that there is, so let us try to understand first support, confidence, and we'll go back to lift. Support is a very kind of a simple formula, frequency data, right? How many times, if I say that sandwich and cookies, like people have been a retail, like a restaurant, when people have ordered sandwich and cookies, next item they have bought a soft drink, right? So let's say this is what I want to prove. If X, if people have bought sandwich, cookies, that is X, then Y, then that is drink, soft drink, they have ordered a soft drink also, right? So this is nothing but a item set. My item is sandwich, cookies, and drink, right? Soft drink is the next item in that item set. So this, which is if X, so X becomes here antecedent, right? The support is the probability that the, so okay. So first a set of items. So the antecedent is which is happening first. So that is X, that is sandwich and cookies. To the right, which will happen next. If I say that they have ordered sandwich and cookies, they are going to order a soft drink, right? So that is a consequent, right? Support is the probability that antecedent event will occur. That means customer will buy sandwich and cookies as the support of the rule, right? So total number of, if I want to understand support of X and Y, right? So what is the chance frequency of X and Y happening together, right? X intersection Y, right? Out of total transactions, if I want to find probability, let's say in that restaurant in a particular day, thousand of orders has happened through Zomato, through people coming in and eating out there, right? Out of those total number of transactions, how many times people have ordered these two items, sandwich, cookies, and drinks, right? So that is the relative frequency, right? How many times that order has happened, right? Then confidence is likeliness of occurrence of consequent on the cart, given that cart already has antecedent, right? So sandwich, cookies, and drinks, right? So first I'll find out how many times people have ordered sandwich and cookies. Let's say I have 1,000 orders in a day. Out of that, only 100 times people have ordered sandwich and cookies. Out of that, how many times they have also ordered drinks, right? So my denominator becomes, rather than total transactions, how many times X has happened, my antecedent has happened, then what is the probability that along with that Y also has happened, right? So if I say that, okay, sandwich and cookies, out of that, so people also would have ordered only a soft drink. Somebody has ordered only a soft drink, right? Somebody would have ordered soft drink along with something else also, right? So not necessarily always with a sandwich and cookies, right? So out of all that, how many times they have ordered along with sandwich and cookies, right? So these are the main basic point of support and confidence, right? The problem happens when we have these value low, transactions containing X is low, right? If this probability is low, automatically your confidence value increases, right? If this is 0.001 or 0.00, if it is like I have right now given you a transaction number around 5 lakh transactions or 5 lakh items being sold, right? So that is a big data. Out of that, if I take relative frequency, all of most of the items will have very small frequency, small probability, right? So what happens if your transactions containing X, right? Let's say number of orders who have ordered sandwich and cookies out of 10,000 or 1,000 orders, so is only 10, right? So no matter, even if it is 1, 2, 3, right? So your probability is happening 10%, 20%, 30%, right? Just imagine two scenarios, right? There are two restaurants, right? In one restaurant, sandwich and cookies have been ordered 100 times, another restaurant 10 times. And both the cases, whenever they have ordered a sandwich and cookies, only 5 times they have ordered drinks, right? So in the first case, when my X size, frequency of X, that means people who have ordered sandwich and cookies is only 10 times, there your confidence is becoming 50%, right? Because your denominator itself is small. In the other case, what will happen? Total transaction number of times people have ordered sandwich and cookies is 100. So 5 divided by 100 is 0.5 percentage. Though in the both the restaurants, people ordering sandwich, cookies, and a soft drink is same 5 only, because my denominator in one restaurant is very small, right? My confidence is automatically increasing, right? So think about two websites. Amazon is a very big website, a lot of transactions happening. Another is a small startup, right? Very few number of transactions. Automatically for some items, confidence will be lot high. So you'll start to believe that whenever this purchase is happening, the other purchase is also automatically happening, right? So to avoid that case, we do something called lift, right? So simply, if I want to understand lift, let's say I have two items, right? Apple and orange, right? And I'll show you that same example. If I say that, okay, apple and oranges bought together, right? So that is the intersection, both the items bought together, right? How many times they are bought together? Intersection of people buying apple and intersection of people buying orange, right? When I say both the events are independent of each other, right? Though are both are happening independently, there is no relationship, there is no association. I'll not say relationship, there is no association in that purchase, right? So this is a separate probability, this is a separate probability. So lift is nothing but if I believe there is an association. So if I believe there is an association, that means P intersection apple and orange, right? Divided by probability of orange happening multiplied by probability of apple happening, right? Let us try to understand through an example. So this is something known as a transactional data set. I have transaction IDs and what kind of items being purchased. See, here it is not the quantity, right? So quantity data will be irrelevant for us, which is unfortunate, right? Because that is something again we have to look into how much the total quantity has been bought. So here what happens? We are not looking into how much quantity of apple has been bought. What we're looking into in a transaction one, what are the items that customer has bought? He has bought apple, one means he has bought, zero means no. So the person or the transaction one, he has bought apple, orange, grapes, plums, green apple, and banana. Strawberry, that person has not bought. Similarly, transaction two, whenever one is there, that item has been bought. So if I want to understand how many times, whether if some people are buying apple along with that, what is the lift or what is the confidence or what is the support that they are buying banana, right? Support will be very simple. How many times they are bought together? Probability of apple intersection of banana, right? How many times apple and banana have been bought together? So apple, how many times has been bought? So in out of 7 transactions, 3 times apple has been bought. Banana 1, 2, 3, 6 times, right? Out of that, if you see transaction ID 5, right? So that person has bought apple, banana. Transaction ID 1. He has bought apple and banana. Right. So these are the two instances, two transactions where apple and banana has been bought together. Right. So support will be P X apple intersection Y banana. Right. 2 by 7 by 7, 7 is the total number of transactions. This is 0.285. That means out of total number of transactions, right, 28.5% of the times these two items has been bought together. Now the question is, how many times when you have people have already bought apple, right, they have also bought banana, right? So same intersection, whatever, two times they have bought. How many times apple has happened? Apple has happened 1, 2, 3. So 2 by 3, 0.667. Other way around, if I had told, how many times people have bought apple when they have bought banana, right? What will happen? What will be the confidence? So here what I'm trying to find out, how many times Y has happened? Y means banana. How many times people have bought banana when they have bought apple, right? If my rule is something different, how many times people have bought apple when they have bought banana? So banana becomes X. So what will happen?
So it will be 2 by 6.
Yes. So your denominator will become probability of X, and X will become that time banana. Total 6 times it has happened. 6 number of transactions people have bought banana, right? Now look into the formula of lift. P X intersection Y, that means how many times they have bought commonly, like together, right? So that is anyhow 2 by 7, what we got. This is the percentage. How many times they have bought independently, right? So think about, so this formula Px intersection Y, when there is no actually commonality, right? That is nothing but Px multiplied by Py, right? So that is the rule of probability, right? If there is no intersection, it is probability of two items is probability of X multiplied by probability of Y, if there is no commonality, right? So what does this rule say, right? Numerator says what is the commonality or association between two items. Denominator says imagine that there is no association. Imagine that those two items, those two probabilities or frequency of happening is no association, right? So Px multiplied by Py suggests that, or imagine that, assume that they do not have any association. Above all, Pax underscore Y is there is a association, right? So here I'm getting a 0.778. Then how to like kind of get this, like, or how to interpret this if I get a value of 0.778, or let's say I get a value of 1.8 or 2, right? So leap, like I said, if I believe there is no association, right? So randomly it happens. Somebody bought a apple, then banana. It is a random association. That is a randomness, right? Randomly somebody is buying. He did not intend, right? So randomness means it is not, there is no order, there is no structure, there is no association, right? That if that is there, right, now what happens? The 0.778 means 77%, right? Your probability of association is 77% of probability of non-association. That means your probability of non-association is greater than probability of association. That means those two items being bought separately or are not at all associated is much more than probability of, because your denominator is high, that's why your ratio is coming less than 1. So whenever your lift is less than 1, what it suggests, actually there is no inherent association between those two items purchased, right? Whenever lift is greater than 1, right, it suggests that the interaction effect, not interaction, association, interaction is a wrong word here, the association effect, association of purchase between two items is much more than if I believe they are randomly being bought, right? So this is where Leaf is much more useful, because like I said, there can be two website, two retail outlets where confidence might, because number of transactions becomes for the item less, the confidence automatically increases. In those situations, if you have two rules or two item sets to compare, look into the lift value, right? So ideally, what should be the lift value? It should be greater than 1. Greater than 1 means, again, the management has to decide minimum how much lift is required, right? But again, like at least if it is greater than 1, you know that there is some association. More the lift, more the association. If let's say lift is 10, what does it actually mean? So if randomly sales happen, right, there is no association. But whenever the combination of sales happens, it is 10 times more than the random sales of two items, right? This the other example what we are thinking. Most of the times, people when they bought a bread, along with that they're buying milk or eggs, right? So there is a huge association, right? On over the whenever they are like bought separately or independently, right? So lift means when I know that most of the times there is a higher chance that they will be bought together, right? So this is when I'll be putting those items or putting those products in the product cell together, right? So whenever, so basically we put certain minimum support. See, why we put a support? So let us try to understand how this algorithm works. So I have these items transactions depending upon how do you set, right? How many items will be bought or sold together, right? And you are trying to create a rule, right? So automatically it will be creating a different, okay, we will get to that. Again, this is a calculation. Support is P inter X intersection Y. N in X intersection Y is the number of times both X and Y is purchased together, and N is the total number of transactions, right? Why it is important? Support defines, imagine like I have given you a transaction data set which is very big, right? So it will be very like kind of time consuming to go through all the data sets creating. So now what will think? Let me just look into if like some items are only bought once, right? Then support will be very small, right? Frequency of purchase. Support is nothing but frequency of purchase, right? Some items, 2 or 3 items are very like rarely bought, right? So when you define support, okay, minimum support is 20% or 30%. What you are looking into? Frequency of purchase, right? At least if the items are being sold 30% of the time, 20% of the times together, then let me go and look into that. Really, sometimes 5% of the time, 2% of the time they have been sold together. That is not something I should look into, right? Because every day millions or billions of transactions are happening, right? It will be very time consuming if I'm looking into that venue also, right? So what is the assumption? What is the wrong assumption here, right? What is something we are missing here? So the uh, like kind of statement I made is correct. Generally, when we are looking into support, what we are looking into the frequency of purchase. If the higher frequency has happened very high, I'm looking into that data set only. Like let's say out of million of transactions, I'll look into the 10,000 transactions or 1 lakh of transactions for which the frequency is high, right? Then what is the wrong in this assumption or wrong in this statement? Or what will be the difficulty you will face if you like follow this approach? So, and it is not, I'll not say like kind of how to like kind of say this. That is not a wrong thing about the algorithm. That is something which this association rule mining, at least in the SAS, misses out. So it doesn't actually take into consideration the price, right? Frequency might happen rarely, right? But if I know that the price of the item is very high, two like expensive items are bought together. Somebody who is buying a Rolex watch, along with that, he is buying certain ornaments, right? Cufflinks, right? It might happen rarely, but if those items or value of those items is very high, I should look into that also, right? But unfortunately, here we are looking into the frequency data only, not the value or worth of the item, right? And second thing, like we suggested, quantity of purchase. When you look into frequency, you are just looking into whether that person bought or not. But somebody buying only once or twice in a year, but huge number of quantity. So that is something which is at least missed out in this standard or the template version of your SAS Enterprise Miner. Is my question or what I'm trying to tell is clear or not? Two important things in any transaction data is quantity and the value of the item. Unfortunately, what we are just looking into the frequency of purchase, right? Number of times. And when I say number, in my transaction data set, I'm not looking into how much quantity was bought, whether that item was bought or not, right? So that is where this miss is happening, right? Am I clear on this?
Yes, sir.
Sir, I have a question.
Yes, yes.
Sir, the frequency, sir, this market basket analysis, will it not be suitable if we use it for some particular category, or if we categorize the items? For example, you said frequency of purchasing the item. So there are some items that need to be purchased weekly, and there are some items that need to be purchased monthly. For example, if I want to buy bread, so it will be purchased weekly. However, if someone decides that they are buying wheat or they are buying rice, so it will not be purchased daily or weekly. It will be purchased monthly.
Correct.
But sir, over there, if we just say that the frequency, so will this not create a problem there? Because there
Yes.
might be a possibility that rice is more valuable than bread, but we are only taking the frequency into consideration. So we are prioritizing weekly frequency over monthly frequency.
Yes. So this is where you have to look into what is the range of the transaction data set, whether you are looking into the daily data set, weekly data set, or monthly data set. What you said is correct, because if somebody like I said, some items frequency will be very less, but that doesn't mean that they do not have value or there is no association, right? Here, the what algorithm we're looking into, which are the same range. Like let's say if I'm looking into the weekly data set, in a week, what are the items are being purchased together? Or let's say if I'm looking into the monthly data set, so the analysis of weekly data set will be different than monthly data set, right? So if you look into Amazon, so the recommender system, which is for the grocery items, will be different than for books, than for your fashion items, right? Because somebody buying a book, maybe yearly or monthly or 3 months down the line, he is buying, right? So their algorithm will be completely different in the grocery item, right? But unfortunately, what happens even then, the value of the item is not taken into consideration. You are buying something very costly, let's say in a dress from Amazon. Along with that, you buy certain, let's say, ornaments and all those things. Both have high value, right? So even if it happens yearly only 2 or 3 times, it is going to give me added value, right? So that is where there are different algorithms. There is something called FP algorithm, AIS algorithm. Other algorithms are utilized, not the one which we are talking about, which takes care of the frequency and value also. What we are just looking into is only the frequency data. Frequency again, not in the terms of quantity. It is only in terms of whether somebody has purchased that item or not, 1 or 0, right? So what you said, the transactional data set, when we kind of analyze weekly data set, that will be like not in terms of weekly or monthly. For different kind of categories, the analysis will be different. If I am like trying to analyze books, purchase of books, or purchase of fashion items, purchase of grocery items, I have to write 3 different type of algorithm, 3 different type of association rules, because the transactional data set will be completely different in those 3 cases. So books purchase, not that every day, every week somebody is purchasing. There will be people, but most it will be monthly basis. Somebody will be buying certain items, right? Grocery items, weekly basis, right? Fashion items, maybe quarterly basis or monthly basis, right? So this is where the differences will come.
Okay, sir.
Any other question? So confidence is if that item has happened, right? If X has happened, how many times within X, like whenever X has happened, how many times from that, like we discussed, 7 times or 6 times this, or 3 times apple was purchased. Out of those 3 times, how many times banana along with apple was purchased? 2 times only, 2 by 3. Only problem happens when your probability of X is less, right? So that item itself is very infrequently being purchased. Automatically, your confidence level will increase, right? Like I gave that example, 2 restaurants uh, being items bought together or being ordered together is less, but because the number of transactions in one restaurant is small, your confidence level automatically increases. That is where we have to look into both lift and confidence. Lift overcomes one disadvantages of using confidence. What I said, like if the probability of X is less, then it will like your confidence automatically increases. So this is when we look into both X and Y, right? Multiply that. We believe that both are independent. There is no association. So take the ratio. If we believe there is a association in comparison to if you believe there is no association. what is the lift in that, right? If lift, let's say 5, so what is the result that 5 suggests? If I believe there is no association between two items in relation to that or with relative to that, when I believe there is a relationship between those two items, 5 times more transactions happens, right? So I should be safe enough to say that there is certain association. So I should put those items together. So whether I should take 5, 10, 15, 40, depending upon how much like a data set you have, how many items you have, that is something we have to look into. So these are the three important parameters we have to look into: your support, confidence, and lift. Then how does generally your algorithm works, right? Find all frequent item sets, right? So that is where you will define what is your minimum support level, right? Because otherwise, if let's say right now these 5 lakh transactions are there, it will be huge item sets, right? Now you have to tell what is the minimum support level. Minimum support level is minimum frequency level, right? This many times the purchase has happened, then only consider that as an item set, right? So like that, item sets will be generated. What do you mean by item set? So you have to define what should be the size of the item set. How many items would be there in a set? 3, 5, 4, 2. If I say 2 items, that means item sets will be generated only with 2 items. If I say 3, 3 items, right? Now, once you have defined your item sets, right? And out of that, depending upon your minimum frequency level, if I say that minimum frequency level is 0.3 or 30%, that means any item set which do not have a frequency of 30%, out of 1 lakh transactions, it has not happened 30% of the time, sorry. It will be discarded from your kind of next analysis. Then generate association rules from the frequent items. Now the calculation part will happen. So what are the association rules? If I, let's say these, I have decided 4 is my length of my item set. That means 4 items. So and this is a frequent item set. What does it frequent item set means? That means it is greater than the frequency of these items together being purchased. So remember, what is the formula of support? The frequency of those items happening, X and Y happening. In this case, it is not X and Y only, X, Y, Z, and A, right? So there are 4 items. Is a frequent item set. What does it mean? It is greater than the minimum support level what I stored. So this item set has a frequency of purchase more than 30% or 20%, what I have defined, right? So that conditions has been met in the step 1. So once that condition has been met, now we'll create association rules. So if I have this item set, what kind of association rule I can say that these 3 happening, bread, egg, and milk bought together, then butter, somebody has bought butter. So there are different combinations, right? Egg, milk, butter, then bread, bread, milk, butter, then egg, right? So this is where, or bread, egg, milk, butter, these 2 items bought together, then other 2 items. These 2 items bought together, then other 2 items. So, or only 1 item bought, then what is the frequency of these 3 items bought together? So this is something, again, manually doing will be like kind of very difficult for that many transaction data set. So this automatically your algorithm or the software will keep creating. And for each of these item set or a rule, basically it will say that what is the lift, confidence, and support, right? Then if I say that no, minimum lift has to be 5 or 2 or 10, accordingly your that item sets will be like kind of generated, right? So this I'll show you in SAS Enterprise Miner. Same data set we'll be using. So these are, again, like we have discussed something retail, we are using telecommunications, these OTT platforms also we can be used, banks, credit card profiles, fraud detection, right? So this is again interesting, right? If whenever credit card fraud happens, these are the certain purchases happen together. So opposite way, you can say that whenever these kind of purchases happens, that suddenly your credit card, you have not informed your bank you are visiting outside India, and certain transactions happening outside India, automatically your card gets blocked, right? That is where the association rule. If the purchase is happening outside your PIN code, that means there is a chance of fraud. Not necessarily always, right? Sometimes you might be traveling and you have not informed your bank or the credit card company, right? then again you have to call and provide certain identity, and those card will get unblocked, right? Insurance, again same thing, like what kind of fraud management, what kind of general claim happens together, right? How frequently those things happen. Medical, like I said, certain kind of infection diseases happen together. So doctors, once they know that okay, these diseases and these two diseases has happened, or these two infections has happened, what is next, what might happen, right? So this is where, again, for all of this you need to have this kind of data set, right? If you're not collecting that kind of information, it will be pretty difficult to carry out this kind of market basket analysis, right? So please open SAS Enterprise Miner. We will work on this data set. First, let us upload this data in the SAS Studio, then we'll come back and visit this SAS Studio. So I had already uploaded, but let me show you again. So market basket analysis file, I'll store this. I double clicked in that file. I'll store it in my use 2000 market basket analysis. Today is 11th April. So I'll run that. This is Excel file. We'll convert this into a SAS file. Right. It will take a little bit of time. It is a very big data set. Okay. So this is the data set: invoice number, description, quantity, invoice date, unit price, customer ID, country, right? So where is this file? So I'll copy the directory path of that folder. Now I'll go to new project in the SAS Enterprise Miner. So, okay, I'm not sure. Just a moment. So now I'll go and so simple steps, same repetitive steps. We'll go and put our file path, clip name, MBA. Data sources, create data source, SAS table, table name. Now we'll go and link that, right? MBA 11th April. Next, next. So this is important. So remember what only we are going to analyze. Like I said, frequency data, price data, country data, these are not required for us, right? So these are the items which will be rejecting. Stock code, reject, country, reject. Because we are only as kind of interested in the description of those products and automatically the frequency or how many times those product in the transaction has happened, we want to find that, right? Customer ID, keep it as ID, description. So this is important. This is target because what your algorithm is going to analyze this part, right? This is the target data. Invoice data, invoice date. Okay. So this is again an ID variable. You can keep it or reject it, no problem. Invoice number, again, it is of no use to me. So either you can keep invoice number as ID or a customer ID as ID, right? Quantity. So this is a, like I said, one problem with this standard template where we are not using quantity, right? Quantity or the price. So again, either you analyze your description or stock code also, as long as those stock codes are different for each of those descriptions. But we are going to analyze description because it is easier for us to understand what is those items, right? Rather than stock code. So the main idea from this, what we are going to analyze, we are going only to analyze those descriptions, right? Whether those items were purchased in a transaction or not. We're not interested what is the item value, what is the quantity, who bought that, right? We are only interested in what is the description in that item, whether in the transaction was there or not, right? The software is going to calculate or find out. Is this part clear or anybody having any doubt? Only thing what you have to do, description, either description or the stock code. So stock code is the that identification of SKU ID, right? Either that or description. So we are putting description because it is easier for us to read what is that item which has been purchased. So next, no. So role, again, remember this is a transactional data set, right? So this is not that we are going to create a test or training or any kind of data set. So this is a transaction data set. So this role you have to change it to transaction. Okay. So diagram, again, just drag it here, your file, right? Now go to explore. If you go to explore, there is something called market basket. So this, drag it. So link it. So now you see what are the items, what are the information given. Maximum items means how many items are there. You are trying to tell that how many items maximum will be there in your item set. Item set means when item one item set, number of items are there, right? Number of those items which is given in that data set is there. So that is what you have to define. So when I'm going to recommend some customers, how many items I'm going to recommend? So how many items should be there in an item set? 2 or 3. So let us start with 2, then we'll jump into 2, 3. Minimum confidence level. What is your minimum confidence level? That means if X is happening, how many times out of when X has happened, how many times along with X, Y has happened? 50%. 50 means 50 percentage. 50 percentage, 60, 70. That number again, you have to, if management says at least 50, so though that is the criteria you're putting, or you can change it to 30. Minimum confidence level has to be 30. Where is this support type percentage? Support count here it is very less, 5, right? So that is 5% frequency, right? See, because it is a very big huge data set, denominator is very big, right? So if you put 30, 50, you'll get very few items, right? You might not get anything. Maximum support might be 2 or 5 something, right? Support percentage. So maximum support, so sorry, this is support count, right? How many items, like frequency, right? How many times that items were being purchased, that is frequency. This is the percentage. This divided by total number of transactions, right? So that will give you minimum support percentage. If I change it to 20, so for a small data set, yes. For a big data set, imagine like out of 5 lakh times 20% means 1 lakh times those items would have happened together, right? So this is where it is given 2% here, and I'll keep it like that. But if it is a small data set, you can change it to little bit higher support and look into that data, right? So for your class exercise, I'll show you the data set, and that is a very like I think 1700 number of observations, right? So so these are the only things you can play with, support, confidence, and lift, correct? So lift size here, it is nothing given, minimum lift is nothing given, right? So all the values will be given, or I can change it to 2 also, right? So I'll do that later on. Let me just run this now, and I'll change some parameters and run it again, right? So run this first without any changes, whatever was given, we'll keep it like that. Results. So you'll get something like this. What we are actually interested in the table, right? The table which I showed you in the. So go to the rules, click on this rules table, right? So and let us try to understand what is this. So there are some items written here. Sorry. Support, confidence, lift. So let me first identify which is the. So this item rule has a lift of 42. What does it mean? This is what paper cups, 6 call paper cups. So that is my X. If that item has, am I audible? Hello.
Yes, sir.
Okay. So what does this says basically? If this item has been bought, along with that, how many times pack of this other? So this is what it is, paper cup. This is paper plates, right? So paper cups has been bought, along with that paper plates has been bought, right? So what is the confidence, right? So that is 91%, right? 90% of the times, obviously that is true, right? Plates, cups has been bought, along with the plates has been bought, right? Uh, Similarly, if you see, this is almost, this is more, 95%. Whenever plates has been bought, out of that 100 times if plates has been bought, 95% of the times along with that cups has been bought, right? Obvious, this is obvious truth, right? Then what we are interested most of the times is lift. If I believe that there is no association between those two, and if I believe there is some association, so what is the ratio of that? So that is 42 ratio, that which is very big. So that means in the ratio, if when I believe there is a association, that is 42 times number of transactions than when I believe that there is no association between sales of these two items, right? So like this, you can look into the minimum support level. So this is the support means how many times, what is the frequency of these two items being sold out of those 5 lakh transactions, right? Support confidence means how many times. So if I looking into this rule, rule number 791, number of times plates has been, sorry, cups has been sold, how many times out of that plates also has been sold. So that is 91% of the time. Then lift I explain. So this is what we are interested in, the rule table, right? So if I just change certain parameters, let us try to see what happens. I'll go to the my table. What now will tell minimum lift required is, let's say 10, right? So because it is a very minimum confidence level, let's say 60, right? Maximum items now will change. So what I'll say now, you can put not only 2 items here. If you see the rules which has been given to you, only 2 items in zone. Also let us put 3 items in an item basket, right, and see what is happening. Now I'll run it again. Results. So go to view, rules, rules table. Okay. So if I again segregate by my leave percentage, again these are there, but now you see like now it is also creating item number 3, right? So if I look into the rule, what it is saying. So if I just look into the rule ID number 551, right? So what is the, whenever this herb maker's child has been sold, along with that, how many times herb maker thyme and herb maker parsley has been also sold. So this is again a, so here what I've sold, why these changes has happened. Earlier case in your maximum number of items in a set was 2. Now I've changed it to 3, right? So this is what the rules for 3. So there are 3 items being sold together, right? So this is how you can do a lot of trial and error and see that what are the kind of items would be sold together, right? Again, you can look into the leap number, confidence number, support percentage. Support percentage minimum we have told 2. So less than anything greater than 2% of frequency will not be shown in this table, right? So is this clear or anybody having any doubt?
Uh, why
Yes,
we
sir.
are taking support percentage as 2%?
No, you can increase it. So what happens, because it is a very big data set, right? Lot of different items are there, right? So in that case, just support means what? It is the frequency, right? Frequency of items occurring together, right? So frequency itself will be very small. But if you have a very small data set, let's say only 1,000 transactions, right? So 10 means or 20 means how much? 20 of or 50 means 5% of that many transactions. You can take that. But even if you have 100 transactions or 200 transactions, in this case, just see 100 transactions has happened like this, right? So 101. So this is 101 transactions like this has happened. But if I look into the percentage system, it is only 2% of the total number of transactions, right? So if I increase it to, just let me show you, if I just change it to, where is this? If I say that my minimum support percentage is 5, that means what I'm looking into, at least that transactions has would have happened 5% out of total 100% transactions, right? Now if I want to run it, I might not get any item set, because that means so there is no items, no transactions which has happened that frequently, right? So that is where your business intelligence has to come, because you might not have like that is a very big number of transactions. Let me show you this. See, number of transactions. So these are the items where you have support percentage greater than 5%. These are the only items. So maximum is 285 transactions. So what does it mean? These 2 items, these 3 items, sorry, this is a 2 items. Teacup, saucer, and what else? So item 3 is, okay, only the color is different, right? So this is some pink color teacup and saucer, along with that green Regency teacup and saucer, right? And this is rose. So 3 items together, right? So both item is same, only the colors are different. Rose color, pink color, and green color, right? How many times it has happened? 250 times, right? So this is the support percentage, 5% of total number of transactions. So now when I made that minimum support is 5%, only these are the item transactions which is beyond the transaction. When just remember when we had 2%, what are the other items were shown? So this is something again remaining upon how many transactions are there, you have to look into that data. If I just increase the support percentage, that means my algorithm only will look into the data set which have above that frequency level or the percentage level of transactions.
Okay, sir.
Okay. If you have a small data set, the example which I've given you is a small data set that you can look into, and I anyhow have given you the support percentage which you have to look into. Where is this? Just okay. For your class exercise, I have not given you any data set. What you have to do, you have to use something which is already available in your kind of SAS folder, right? So where you have to go to data sources, create data source, SAS table, next, browse. So I've given you the path in your yeah. So if you go to the sample folder, SAMP SIO, right? So there is something called association rule, ASSOCS, right? So this is the file which we'll be working with. That is around 1700 transactions. So I have asked you to change different support, different click level, and try to see that what kind of insight you are getting, right? So that is your yes, class exercise, right? Anybody having any doubt? So for this class exercise, I'm not giving you any data set. So data set is already there. So you do not have to upload anything in the SAS Studio. Open SAS Enterprise Miner, create data table, go there and select that file, right? You need not have to write that leave name and all those things. Clear? Yes, Abhijit. Yes, Abhijit.
Sir, yes, sir. Yes, sir. In the assignment you have in the last question, if you update the minimum lift of 2, then what is the reduction in the number of association rule? So, sir, for that, if I so what will be the the first lift? Like I have
So
to take
fast
more
lift there is
than 2.
so fast lift is nothing is there, right? So there is no limit for the lift. So automatically when you run this market basket analysis, minimum lift nothing is mentioned, right? So it doesn't have a limit. So now what I'm telling you, if you change it to 2, right? So now initially how many rules were being told, then when you say that minimum lift is 2, how many rules right now you were showing, right? So that is how you'll find out the reduction. So initially without any limit, minimum
Yes,
lift limit, then when you change it to update it to 2, how many rules are showing now? So that then we'll come to know that how many reductions happened.
okay, sir. So that the number of rows are getting decreased.
Yes.
Yes, sir. Yes. So got it, sir.
Like right now, I changed from your this support to 2 to 5%. When it was 2%, only lot many rules were there. Right? When it was 5%, only how many? 15 or 20 rules were only
15
there.
or 20 rows are there. Yes, sir. I see.
Okay. Yeah. So if there is no question, we'll stop here for today. Please complete the exercise. Next class we'll do something interesting. We'll try to build something called credit score model. So those of you who are into finance, so that will be very useful for you. Okay. Chalo, take care. Bye bye.
Sir, I missed my attendance.
Roll number 121. Okay. Okay.
Thank you, sir.